welcome back. In this lecture, we're going to have a look at SD cards as a convenient way to store large amounts of data outside the Arduino. The Arduino has a tiny amount of memory in which a sketch can store data, and where the sketch itself can be kept. The Atmega microcontrollers in the Arduino contain three types of memory: SRAM, Flash, and EPROM. Static RAM, or static random access memory, is volatile and is where your sketches store values that belong to variables from things like sensor readings. Volatile memory is cheap and fast, but as soon as power is lost, it is erased. Therefore, it's only used as a temporary place to store data. In an expression like int LED pin equals 13, you are storing the number 13 in static RAM. In the Arduino Uno, where the Atmega 328 is used, there are only 2000 bytes available in the static RAM. It sounds like it's a lot, but it isn't. Your computer probably has 1,000,000 times more RAM available to the programs that run on it. Flash memory is non-volatile, so when power is turned off, its contents remain safe. Flash is where your sketches and the Arduino bootloader, which is a special program that helps the Arduino start executing the sketch when power is applied or with uploading a new sketch. That's where they're stored. The Atmega 328 has 32,000 bytes of this memory. You don't normally use this memory to store data, but you can if you want to, and this is a topic for another lecture. If you're curious, have a look at documentation for the procmem keyword. Finally, EPROM, or electrically erasable programmable read-only memory, like Flash, is also non-volatile. It is a good place to store data permanently that should not be erased in case a new sketch is uploaded. Things like serial numbers, IDs, and the like can be stored here. The Atmega 328 has only got 1000 bytes of EPROM available, so it's definitely not much storage. On the Arduino, onboard storage is very limited. For applications like data logging or running a web server with multiple pages and images, the built-in memory is not enough, so we turn to SD cards for help. SD cards have matured over the years. Their sizes have expanded to many gigabytes and the prices have dropped to a few cents per gigabyte. Compared to built-in memory, SD cards offer a really good mass storage solution. On the Arduino, an SD card can be used with the appropriate hardware extension and with an easy-to-use library that comes with the IDE. Your Arduino Ethernet Shield comes with a micro SD card slot, but you can also get them as a separate breakout board. In this lecture, I'll show you how to take advantage of SD card mass storage using a cheap, less than $2 on eBay, breakout board. The SD card that I'm using is an ancient 256 megabyte card. Still works fine. Before getting into the demo, there's one more thing I need to discuss. That's the SPI bus. The SPI, or Serial Peripheral Interface bus, is a way of connecting multiple slave devices to a master. Unlike IC², which we played with back in Lecture 9, where we learned about the BMP08 barometric sensor, the SPI bus provides full duplex, which is two-way, communication between master and slaves using two wires. The IC² interface supports half duplex, so that data can only flow in one direction at a time. There's also a wire that provides a clock signal to the slave so that both devices are synchronized, and a fourth wire that are used for selecting one of the many slave devices that may be available. In summary, the table in this slide shows which pins are used by the SPI bus, which we will be using to connect the breakout board to the Arduino. The SPI bus offers itself as a topic for a full lecture, so I will not go into more details now. For now, simply keep in mind the functions of each of the SPI bus pins, and also keep in mind that the actual numbers that are used by your board depend on the board model. So check the documentation to make sure that you're using the right pins. So in this first demo, I'm going to show you how to connect the SD card module. It's already connected, but I'll explain what the connections are so that we can read and write from this SD card. In the first demo, I'm going to use a sketch that contains some code that is not really recommended to use in your own scripts production. It contains it uses several functions that are not documented, so those are subject to change. So it's a really good idea to avoid using them. But the same sketch is part of the examples that come with the IDE. So whenever I set up a new SD card module to work with my Arduino projects, I find it a good idea to use that script to make sure that all the connections are good before I commit my design. So that's the same way I'm going to be using it in this demo. The first thing to do, I'll put aside the Arduino components first. The first thing to do is to format the SD card so that the SD card reader can use it. I want to format it using a FAT16 or FAT32 format type. Show you how this is done on the Mac, and then there's a very similar procedure on Windows computers. I've got my SD card reader. I'm going to plug my really old, over 10 years old SD card in it, just 56 megabytes. And I'm going to move over to my disk utility on the Mac, and you see that it popped up here. So it's you can see 253 useful megabytes. Probably some of the capacity of this card has gone over time. So I'm going to click on Erase, choose my MS-DOS FAT format, and give it a title. I can call it Arduino, and just click Erase. So the SD card is now ready, it's formatted. Let's have a look at the connections that we need to do. So I've got my breakout board upside down, so I can look at the pins. Although this card, this PCB comes with 2 rows of pins, really just the second one from the left, or the first one from the left, is the one that actually has electrical connections. The other one is just there for stability. The particular one I got on eBay for maybe $3 or $4 has got a ground pin which connects straight to the Arduino ground pin, and an option of 3.3 or 5 volts for power. You can use either one. I go for the 5 volts, but just be careful when you connect yours. Be sure whether you should be using one or the other voltage. Some cards are sensitive about what input you provide. Now the data pins, the two, there's MOSI and MISO. So these are the 2 pins that I use to transfer data. First, the MOSI one is master out and slave in. So master, remember, is the Arduino, slave is the SD card reader. So for data that go from the Arduino to the SD card reader, we use the MOSI pin, and that is connected to, let me double check my notes. So MOSI is connected to digital pin 11 on the Arduino, so that's the yellow wire. Now MISO is the other way around. So MISO is master in, so Arduino in, slave out. So that's data that go out of the SD card and into the Arduino, and that needs to be connected to the Arduino Uno digital pin 12. So you need to, if you don't have the Arduino Uno, then you need to double check with documentation for your board as to which pins are used for MOSI and MISO. Next is the clock, so the serial clock that's used for synchronization, and that goes to digital pin 13 on the Arduino Uno. The last one is chip select, or sometimes you might see it referred to as slave select. Because the SPI bus can be shared between many slaves, The Arduino needs to have, or with the Arduino which is the master, needs to have a way to tell which board should now be speaking to it. So for that purpose we use the CS pin, the chip select, or again you might see it as SS, slave select. Now the digital pin assigned to CS is configurable. In the sketch I'm going to show you, I've set it to be pin 10, but depending on what other devices you have connected or sensors, you may be able, or you may want to use one of the alternative digital pins. So most of them should work just fine. So yeah, that's about it with the connections. I'm using a ribbon here to just make my life a little bit easier. Or if you are going for a PCB, you can just solder the SD card directly onto the PCB. Okay, so connections done. What I'll do next is I've already inserted the SD card and I'm going to upload the script. So back to the computer, upload the script. And let's have a look. The card has been initialized. What it's doing is the card's partitions, go through all of them and get any files, print them out onto the monitor. And also what I'm more interested about are these bits of information. So the format that I'm using, the size in bytes, volume in kilobytes and in megabytes, in some calculations here. And it's a completely empty card. However, even though it's completely empty, there are still files, hidden files, system files that are present. So now I'm happy my SD card works. Let's have a very quick look at the sketch. I'm not going to go through it in detail because, as I said earlier, it's not advisable to use the SD card using the functions in this sketch since they are mostly undocumented. But a couple of things I want to point out is first, we make use of the SD library that contains these very useful functions that we'll see in more detail in demos 2 and 3. Declaring bunch of objects here. Again, more about this in the next demo. And the only thing really that you need to configure here is the digital pin on the Arduino that you'll be using as chip select or slave select. And I've assigned it to 10, or in your case, if 10 is used by perhaps another device, you can change it to something that is not used. Okay. That's about it. Try this out, make sure that your SD card reader and writer works, and then move on to the next demo where we'll see how to actually write and read from it.